Hello and welcome. My name's Kito, and I'm here to talk to you about upgrading a legacy Java EE application with style. So we'll be talking about a project that I was involved with recently, and we're still sort of finishing up. That's basically looking at working with an older Java application and bringing it more up to date. So to start out, let me just tell you a little bit about myself. So my name is Kito. You can find me on Twitter at Kito99. And I am the principal consultant at Virtua, where we do training, consulting, mentoring, etc., on basically a wide range of technologies, both front end and back end. So we do work with, of course, a lot of Java, a lot of enterprise Java, Jakarta EE, Java server faces, but also front end development using TypeScript and web technologies like web components and Angular, etc. as well. And we also work with microservices and just cloud technologies in general. I'm a Java champion, which makes sense because you're at a Java Champions Conf. And I'm a Google developer expert on web technologies. And that really gives me sort of an angle on the browser and this basically standards for web development in general. I'm the co-host of a podcast called Stacked. You can find it at stackedpodcast.com. And if you like podcasts, I encourage you to check it out. It's basically me and a couple other guys, and also we have guests occasionally talking about front-end development, back-end development, enterprise Java, enterprise development, technology in general, and a whole range of different topics. We've even had people on talking about enterprise architectures. We also have people on talking about Akka, Scala, stuff like that. So basically, if you're interested in Java and you like podcasts, you should check it out. I wrote a book about Java server faces a long time ago. I haven't written any more books, but hopefully I will before I die. And I also am a member of the Java community process. I participated in a few different expert groups back in the day, and I'm a Jakarta EE ambassador. I should also mention that the intro for this podcast the intro for this session was actually done by my son, who's an 8-year-old, and actually he did that using Scratch, which is a great tool for teaching kids how to write code. So thank you, Alex. I appreciate the intro. So that's it for me. I'd like to hear a little bit about the people on the stream. Basically, what I want to know is how many of you are currently working with like an older Java app, enterprise Java app, and I want to know if anyone is currently working on migrating, upgrading an application from an older technology stack. So if you have any comments, you can just put them in the chat. All right, looks like. All right, so someone said that they've worked, me, okay. All right, so we've got a couple people that have worked with working on a legacy app. Oh, 15 years of history from one person. Okay, cool. Wow, okay. Someone's still working on some things from when I was writing the book. That was a long time ago. All right, Mike. Okay. All right. So a few of you, sounds like a lot of you are in the right place. You've got an older application to work with and you'd like to upgrade it at some point. Great. So this project was basically to take a legacy application and upgrade it to work with a more recent supported version of WebSphere. And this is something we often see where you've got an old code base, it works, it's in production, but there are security patches required for the software that it uses. And eventually, unless it's upgraded regularly, it gets to a point where it's running on some completely unsupported old stack. And that's basically the situation we were in. So the idea was, they're using an ancient version of WebSphere. They want to upgrade to something that's actually supported. And I should mention, I had the pleasure of working with this project, working on this project with Balas C, also known as Bake Schultz. who's an Omnifaces co-committer or core developer, I should say, and author of the Definitive Guide to JSF, which is a much, much newer version of JSF book than mine. And also, if you've ever asked any question about JSF, Java Server Faces on Stack Overflow, you'll definitely find him on there. He's like the Stack Overflow JSF king. So it was really great having him on the team and working with him on this. We're also still working together on other projects. Okay, so as I said, our goal was to upgrade this old project. And it turned out that basically it's well, I'll talk more about it, but it's an older application. It's been in production for a long time. And we wanted to move it to a supported version of a Java application server. It needed to integrate with cloud-based versions of their application. They had actually migrated a lot of the code to a completely different code base, sort of a more vertical-based platform. And basically, they had some lines of business that were still using this old code base, and they were also using the old code base for basic authentication and things like that as well. So our goal was to basically upgrade the app so it was on something supported. It could integrate with cloud-hosted versions of the newer parts of the application. And we knew that it was going to be replaced in a few years. So this wasn't something where, we needed to make sure it was going to be used for 20 years or another 10 or 15 years. But we wanted to make sure that it was actually something that could be maintained and new developers could join the team and have some idea what was going on. So that was sort of our goal there. And another key piece here is that they wanted to replace the existing security with Okta. And this is something that came up a little bit later in the project. After we already started, they're like, oh yeah, by the way, we need to replace all this stuff with Okta. So that was a whole new leg of the project. And if you're not familiar with Okta, it's basically a identity management platform. So it allows you to do authentication. Essentially, it integrates with Active Directory and other sorts of user management solutions, and also does Open Connect, OpenID, JW2 authentication, all that kind of stuff. So think of it like that sort of tool. So the first version of this app actually came out 12 years ago. What is cool about it is that I was actually involved. So I was the person that helped kickstart the project initially, at least the JSF front end portion over 12 years ago. So it was really cool seeing my name on like some old files and, author Kito Mann, stuff like that. And it turns out it's over 550,000 lines of Java code, over 550 JSF pages, and includes, but only half or less are actually in use. A lot of them have been replaced by a newer application. And when we got into it, we learned it's actually more than just one application. It's actually 4 applications that shared some core business logic and services. So there was a back office internal web app, 2 public-facing web apps for different user types, and also some SOAP web services. So I don't know how many of you actually remember SOAP, but it's essentially a way of doing web services that was preceded REST, essentially. And the payloads are actually XML. So it's much more strongly typed, but it's also more cumbersome and has a lot more overhead, etc. So the first thing we had to do is take a step back and say, okay, well, this basically these are Java EE apps. These are essentially enterprise application archives. They're EAR files, which no one really uses that much anymore. And we weren't really, our job wasn't to basically re-architect the whole thing. Our job was to upgrade it to something that was maintainable and make it supportable for a few years, essentially. So first we said, well, we've got a Java EE server, and at the time it was using WebSphere Application Server 7, and that's no longer supported by IBM. So what we wanted to do was upgrade to something newer, and we spent some time looking at, of course, WebSphere Liberty, which seems like a logical choice. And I was really hoping we could use it, but it turns out we couldn't. And moving to Webs for Liberty and Jakarta EE was really what I was hoping we could do, but it turns out that JAX RPC is sort of a problem. So this application uses JAX RPC for SOAP web services, and that's not supported in Liberty or any sort of modern application server. So we were forced to use Webs for Application Server 9, full profile. Which, it's supported by IBM. It's modern in the sense that it's up to date, but it's not nearly as flexible or performant. Well, not necessarily performant, but it's not nearly as flexible or as cool or updated as Webs for Liberty, which we'd hoped for. But the benefit of Webs for Application Server 9, though, was that the infrastructure team was familiar with the whole way that Webs for Application servers are managed, so they didn't have to learn anything new. Which was a plus. So we knew we'd moved to Jakarta E. I wish it was Jakarta E to WebSphere 9. Okay, but then what about the code? So what did we have? We had IBM JDK 6. So JDK 6. So obviously we had to upgrade to a newer version of Java. And we had Java EE5, which is pretty old these days. So that was Servlet 2.5, JSP 2.1, JSF 1.2, JAX RPC 1.1. So it's pretty old things. And on top of it, we had, of course, third-party libraries. So with JSF, it's a UI component framework, right? And you usually use a UI component library. Initially, we thought we might end up rewriting the JSF pages in prime phases, which is the most popular JSF component library, which I've worked with extensively. And the library that this component suite or this project was using is called Infragistics. So Infragistics Net Advantage for JSF. So I don't know how many people remember this library. I actually helped Infragistics kickstart this project way back in the day. But it has been discontinued, and it was discontinued in 2009. Okay, and we worked on this project in 2021. So this project has been discontinued for a long time. So our thought was, man, we're going to have to replace all this stuff. It's definitely not going to work in a newer version of JSF with the new version of WebSphere and all that kind of stuff. We also noticed that they had some components from the IBM Java Server Faces widget library, which ships with Rational Application Developer and IBM WebSphere. So that was another thing we didn't quite expect. So we had to figure out, could we still use any of those components? Did we have to replace them with something else? And then it also used Apache MyFaces, Tomahawk, which was another component library back in the day, which is pretty much not really in use anymore. So this is what we started with. And we kind of had to go through each component and say, okay, what can we upgrade? What can we not upgrade? What sort of issues are we gonna, run into? How can we resolve them, et cetera, et cetera. So it turns out it was a little different than we expected. So first, of course, we tried upgrade to IBM JDK 8. That's the most recent version supported by WebSphere. And fortunately, we found that there really weren't many changes for the language between 6 and 8 in this particular code base. Upgrading the Java JDK was not really a big problem. So that was really nice to see. We were able to recompile it pretty quickly. In terms of the Java EE version, we were able to pretty easily upgrade to a newer version of JSF and Servlet 3. The only sort of sticking point is that we were stuck with JAX RPC. And remember, the reason that we chose WebSphere 9 was so we could still use JAX RPC, because there were quite a few web services and we did not have the budget to rewrite them all, because not only would we have to rewrite the web services, but we'd also have to update the consumers as well. So we basically just had to, use it as is. Our JAX RPC hadn't really changed much, so that was a good thing. And then when it came to the component libraries, we were very surprised to see that we were actually able to continue to use all the same components. So although initially we thought we'd have to rewrite all of the JSF pages using a more modern component framework, we found because JSF is very backwards compatible that we were able to keep the net advantage components. We had the source, but we didn't actually need to make any fancy changes. We were able to keep the Java Server Faces widget library, at least some of it. Some parts of it we were able to very easily replace with newer JSF components or other or similar components. And the same thing goes for Apache MyFaces Tomahawk. Works just fine. Didn't really have to do any changes there. We did have to, in some places, of course, do some tweaks and things like that. But for the most part, we found we were able to stick with the same libraries, which was a big benefit for the project. So, of course, nothing's perfect, right? So what were the pain points at the code level? Well, on the JSF side, we still had to go through every single page, figure out what worked, what didn't. Very few changes for the Infragistics net advantage components. For the WebSphere, for the Java widget library components, some of them were deprecated or removed in favor of a JSF 2.x components, but it really wasn't that big of a deal. And it was pretty easy to figure out which components were deprecated and removed. So that was pretty nice. The web services side turned out to be a little more of a pain because essentially this was a project that it was one of the modules that we're working with, right? And it was all JAX RPC. And one of the more frustrating things, and we've all seen this with different frameworks, was that we couldn't really figure out what was going on at first because we got these weird errors that were more at the framework level. So they were like JAX RPC errors or errors in IBM code before we even got to what we were dealing with. So it took us a while to figure that out. It also took a little bit longer to figure out how to surface those errors properly. We also had some issues with code generation. So JAX RPC is heavily based on code generation. And it took us a while to sort of understand where the code was being generated, how it was being used. And a lot of it was actually done at the build level, which I'll get to in a minute. But essentially, we had examples of deployed artifacts that were working, right? And we had a code base and they didn't really match. We're like, okay, well, where is this code generated? How is it generated? Turns out it was done in the build. And the developers were actually used to build with Rational Application Developer, and they generate all this code during the development process. But none of it was checked in. So just by looking at the code that was checked in, you couldn't tell where it was being generated. So we had to work through all of that stuff, and we were able to get all the code generation into a Maven build, which I'll talk about later. We also sort of set things up using standard Eclipse with our Rational Application Developer and wrote up guidelines about how to create a project or how to work with the code base, et cetera, et cetera. So that's how things went on the web services side. Another thing which I'm sure many of you have run into is poor error handling. And this is a very common thing in code bases, especially one that was written a long time ago and it's just been running in production, because they may not have even encountered the same errors that you're encountering, right? So we had a lot of trouble finding out, root causes of some of the errors that were popping up that probably no one had really seen before. So that was fun stuff. Okay, so I want to talk a minute about security, but Brian, I don't know if there's any other questions that anyone's brought up. I haven't really been monitoring the chat that closely. Okay.
Nope.
I'm sorry, Benny. Called the wrong name there. Were there any questions in the chat?
I think most of them are. We had one. What's the benefit of WebSphere? But I think you went into that quite a bit. It's been in the very beginning, so
right.
Up to you whether you want to answer that again.
Well, it's actually an interesting question because WebSphere. Wait, was the question the benefit of WebSphere Liberty or of WebSphere in general?
WebSphere in general, or
Okay.
what's the benefit of WebSphere compared to Tomcat and Jetty? That was the original question.
Oh, okay, yeah. So it's interesting because I was thinking about this as I was going through the process and getting a better handle on how WebSphere handles things. And WebSphere is a full-fledged Java EE application server. WebSphere Liberty is Jakarta EE now, at least. So it has all the features, all the different frameworks that are part of Java EE, and that includes the web-based stuff like JSF, Servlet, JAX-RS, etc., JPA, but also includes EJB, JAX RPC, of course, being old, and a whole raft of other frameworks, CDI, etc. And also, WebSphere has a whole other deployment layer, which I hadn't really worked with much before. So there is this WebSphere network director that can actually manage other nodes. And it can do all sorts of things. It can push out configuration to them. It can start and stop them. It can deploy applications to them. And this is kind of interesting because it actually, in a lot of ways, it's what people do now with Kubernetes clusters, right? They've got a Kubernetes cluster. They got to push out all these different Docker images. They've got to manage them. They got to start and stop them. It's all that kind of stuff. But back then, it was at the WebSphere level. So it was the WebSphere application server doing that to other WebSphere nodes, which could be containerized. They could be on virtual machines, which is what they were like on in this environment. But it's just a different way of doing things. So hopefully that gives you an idea. I think WebSphere Liberty is much more bare bones from the management perspective. So you don't have this fancy console, the network director thing, and all that kind of stuff. But it certainly is very functional for everything else. So hope that answers the question.
Awesome. Thanks for answering there. That was all the questions. So
okay, cool. All right, thanks, Benny. All right, so let's talk about security, because that's obviously a very important thing. You can't do a migration without actually ensuring that security still works. So before, for the web services, and we had a couple layers of security we had to worry about because we had multiple applications. So from the web services perspective, there wasn't any security. So it's kind of interesting. I've worked at much more, secure environments in the past. This is going to screw up here. Let me just fix this here. And go down here. Okay, sorry about that. Okay, so all of the apps, well, the web services app specifically was on premise with the apps that were actually talking to it. So all of its clients were on the same network. So there was no security. They could just make calls directly to them. There's nothing to worry about. Now, I'd say, in more modern environments or environments that were more security conscious, there probably should have been security to begin with, so that no one can make arbitrary calls to the web services, even if they're on the same network. But this is the way it was. So our job was basically to take a step back and make sure that you could only make authenticated calls to the web services, because now they're going to be exposed to other services that are actually not even in the same network. They're actually running on Amazon. Our project was still going to be. So what we basically did was we added machine-to-machine OAuth to client credentials, and all we had to do is basically write a servlet filter. So we wrote a servlet filter. We actually used the Okta has some very easy to use client libraries that are written in Java, and they also have bindings for other languages as well. So we just used that, and we made sure we protected every single request coming in, and you had to have, of course, valid OAuth 2 credentials, etc. So that's what we did, and it worked great on our test. But then when we started to actually integrate with the clients, the services that were consuming our web services, they were like, hey, it doesn't work because the response we're getting back is not a valid SOAP response. Because we were basically sort of mimicking SOAP. We're not using, SOAP has a whole authentication thing built in, which we weren't using. So we're basically using normal JWT stuff. And we were basically, whoa, what just happened here? That was interesting. And we were basically just sort of mimicking the SOAP style, but so the response they were getting back wasn't SOAP, so that we had to basically go back and mimic a SOAP response, so that we could return proper errors, because it turned out that they were using stubs on their client side. So essentially, they couldn't really control how the error messages were parsed on their end. So there were a couple things to figure out, but not a big deal. So that was the web services side of things. We also have public-facing JSF apps. And before, they were using IBM Web Seal and IBM Security Access Manager, also called ISAM, with another tool that's sort of a proxy level layer called Web Seal, excuse me. And they were using custom database authorization using JDBC and DB2, which is actually running on AS400, which it still is today. And was interesting is that they were using this authentication mechanism for both the legacy apps and the new apps as well. So the new code that they had deployed that was built using a different technology stack was still using this for authorization. So this is, again, one of the new things that sort of popped up once we got into this. Is like, well, now we're using Okta for everything, right? So now we need to integrate with Okta and integrate this old JSF app with Okta. So again, we used a custom servlet filter and a custom servlet for this, and basically integrated with Okta. We had to learn Okta better, had learned how to create different applications in Okta and get all that to work together. So that was a fun part. And actually it is pretty fun working with the security side of things. So it turns out that wasn't too bad with a filter and a servlet. So that's how we handled that part. We also got to remove some of their code as well. On the pain point side of things, the Okta docs aren't really that great. They're okay. They're certainly better than a lot of stuff we've worked with. But there's still a lot of gaps which aren't really covered, so we had to sort of figure that stuff out. Also, most of the job examples are for Spring Boot, which is great if you use Spring Boot, but if you don't, you have to think about it a little bit more. Not the end of the world, but something to keep in mind if you work with Okta. It's something I think the Okta guys should keep in mind, is that not everybody in the world uses Spring Boot. So. Okay, so that's sort of the core things, right? We talked about the application, server, code, security. So what about testing? Personally, I'm really big into testing. I'm not really a TDD guy. I've tried it before, and it's not my cup of tea, but I am a write a unit test for everything sort of guy, and a make sure you have integration tests, all that kind of stuff. So that's how projects that I control run, but that's not always the case when you inherit a legacy code base. So what we inherited were a few ad hoc tests that have been written on the web services layer and on the business layer. And pretty much our take on that was, we're not going to rewrite all your tests. And we're not going to write a whole bunch of new tests for existing code, which has been working for 12 years. But what we will do is make sure that all the existing tests work, unless we deem that it's really not worth the trouble. And, of course, discuss that with stakeholders. And any new code we write, we will write an actual proper unit test for. So that was basically our approach. And what was interesting, when you go back to an old code base, you run into areas where the testing approach assumes there's certain data in the database, that may or may not be there, all sorts of different little things you need to work through. But so that was fun stuff. And I don't believe they were actually running their unit tests with the build. So we had to work through all that and make sure that the unit tests were run for every build, et cetera, et cetera. What helped a lot for us was that we had dedicated manual QA to help compare against the older version of the app. And so I encourage you, if you work on any sort of migration project like this, or anything that's even more complicated, or where you're rewriting stuff, make sure that make sure you have adequate resources for QA, whether that's a manual or automated or whatever. Having the ability to at least compare against the old application is really key. That really helped out a lot of what we were doing. Okay, so documentation. So this is another area which I'm sure you guys have seen that legacy projects can lack in. So before we started this project, we kept on saying, okay, well, where's the documentation on this? Where's the documentation on that? So most of it was scattered, outdated. Some of it was in SharePoint, which they sort of use. And basically, we had them send us whatever they could find. And then we basically had to take it from there. And our goal was to make it so that anyone joining this project or working with this code base later on would actually have some basic documentation to sort of guide them through the process. So we took the simplest route, which was to add documentation to Markdown and README files. Okay, so one of the issues we had, this is something to keep in mind in general, is that a lot of the documentation wasn't near the code, right? So the code base had basically no documentation telling you anything about it or anything, which was actually much more common 12 years ago, right? But these days, you got to have a README file. So the README basically gives a lot of information about, the application, how to build it, how to test it, how to run it locally, how to get it running in Eclipse, all that kind of fun stuff. Some of the more high-level documentation related to architecture or to different deployment environments we put on Confluence and a wiki. But at least now we're at a point where they can actually, if someone who's new to the project can actually figure out what's going on. So that was another key thing. So I encourage you, if you go back to an old project and you have to do this, take that step back and try and make it easier for the next people by doing small things like updating documentation, etc. So let me stop here for a second, Benny, and see if there's any other questions.
We do have a lovely chat with lots of knowledgeable people, so most of the questions are answered immediately by the chat. Thanks for that,
Awesome.
community.
Thank you, chat.
So there's nothing left for you to do, I think.
Okay, awesome. Thank you. Okay, so let's talk about version control then. This is another thing you'll find with legacy environments. Although those of us who work with open source a lot and tech companies, we're all used to Git, right? Everybody uses Git. But in reality, that's not always the case, right? So the source code for this application was actually in this legacy version control system called MKS Integrity. It was actually used only for this code base. All of this organization's newer code was actually in Subversion, and they were looking to move to Git for this part of their new projects. So, but no one here really touched this code in a while, so it was sitting in some ancient version control system. So our take on it was, well, if you're using this ancient system and you're talking about moving to Git anyways, let's just move all your stuff to Git and not worry about what's going on in this control system, this version control system. And what was key about this was not only did we want to basically remove another maintenance requirement for them and make their lives easier, but also there were some build deployment steps that had to do with MKS features. So this was an opportunity to sort of get them off of this as well. So we actually did a really clean break, and they were okay with this. Not all organizations would be, but we basically just copied all their new code to Bitbucket. And as a result of this, we lost all of their history. We also found out later that we didn't even have their most recent version of the code. So there's obviously risks with this, but it worked out in the end. It worked out quite well. So that's the first thing we did there. And of course, the issue we ran into was that the team wasn't too familiar with Git. So of course, there's a little bit of training involved in getting people up to speed with it. But they kind of needed to do that anyways, so it wasn't really a problem for us. Okay, so that's the version control side of things. Now, what we learned once we got into the project, that the build side was actually really big. So I said before that, whoops, sorry, wrong direction. So their builds, part of it was done by the version control system, had to do with builds and releases and stuff, but that wasn't really the big issue. So it turns out that the build scripts were actually a whole bunch of Ant scripts, custom Java code, Python running on a Windows box. They did use Jenkins, and the Jenkins would run the Ant scripts and everything for builds and deployments. And this is sort of where I was sort of dovetailing with the code generation. We actually had a lot of the code generation happening inside of the build process. So this is what I was saying earlier, where, you know, when we were looking at the code base, we were like, well, how is the code generated? When we found the build scripts, we're like, oh, okay, it's generated here. And then the developers were actually using Rational Application Developer back in the day, which would do the code generation for them. So they were fine. So that's the way things were when we started on the build side of things. Now, fortunately, we were able to clean all this stuff up. As I said before, we moved them to Bitbucket. We used the multi-pipeline Bitbucket plugin for Jenkins. We ran the builds on Docker using Red Hat Enterprise Linux, excuse me. And I tried as hard as I could, but I couldn't. Saw someone talk about rewriting 12 years old business logic. Yeah, that's scary. Okay, so we were able to get the build running on Docker, etc. And we tried to get rid of use of Ant, but it turns out we couldn't really do that because several IBM Ant tasks were used by the original build, and they were mostly for some of the code generation stuff. And these Ant tasks had not been rewritten for Maven or anything else. So we basically, it turns out Maven has very good interop with Ant, believe it or not. So it wasn't too hard to reuse the Ant tasks we had to reuse for build and deployment. And we also found there's this really great WebSphere Maven plugin. So we were able to use this for actually deploying to the WebSphere network director, which is responsible for actually deploying to the other WebSphere servers. So that was actually kind of nice to work out. We had to do, a few hacks to get the Eclipse WebSphere plugin to work with WAR files, which is interesting because I said earlier that this application was using Enterprise Application Archives, which are EAR files, which aren't really used very much. So we, of course, changed the build to just use WAR files. And the WebSphere plugins didn't like that, so we had to do some tweaks for that. But at the end of the day, we had a lovely Maven, multi-module Maven project that generated 4 WARs. So essentially, we basically modernized the build process, but did not change the functionality of the application because that was beyond the scope of the project. But at least we were able to get it up to a modern build process that they could easily manage going forward. So pain points. So this turned out to be, again, a big part of the problem. This particular organization did not have a Maven repository internally. So basically, they had a whole bunch of jar files that were stored on disk. And they actually even had they were actually stored in version control as well. There was a project that just had all of them in version control. And we went through all of the different libraries and found that some of them weren't actually in Maven Central at all. And And a lot of these are old libraries, right? So of course the Infogestics Net Advantage libraries weren't in Maven Central. Number one, they're commercial, and number two, they've been discontinued for over a decade. But some of the other libraries we couldn't find in Maven as well. And since this organization didn't have a plan to move to a Maven repo internally, like using JFrog or like Artifactory or something like that, we basically ended up having a local Maven repo that we stored in Git, which is sort of an anti-pattern, but it was really the best we could come up with. So we still use Maven. It was still a local repo, but we basically using it as a file storage mechanism. Hopefully in the future, if they ever do more sort of standard Java development, they will get a repo, but that's not the way it is currently. So another issue we ran into was character encodings in source code. So of course, keep track of that stuff. That caused a couple bugs. And that mainly had to do with some people using Windows and some people using Linux, etc. And I'm on a Mac. Some of the libraries required the IBM JDK. So initially we thought, okay, well, we can build with any JDK 8. Turns out that's not true. We have to use IBM JDK 8. That had another issue, which is that it's sort of a pain to get the Mac OS version of that. It's possible, but it's kind of a pain. So, so this is another thing we had to deal with. And of course, the integration with the Ant Maven tasks was fun stuff as well. Okay, so that was the build side of things, which was definitely fun. After a few months, we got through this whole process, migrated all this code, got it up and running on WebSphere 9, deployed to multiple environments, talking to Okta, integrating with the not third party, but the other services that were consumers. And also I didn't mention this, but there's also code going from our web services to other web services as well. And all that stuff was working fine. So we were able to get through all that. We were able to get people, QA, to actually test the application. I'm not sure it was actually faster or better, but it definitely worked at least the same as before, with, of course, the changes that were required for the work we were doing. And there's a few key takeaways here. So the number one takeaway I want to leave you with is Java and Jakarta EE are extremely backwards compatible. And this is, I think, one of the very underappreciated features of Java. And it's really key here because, remember, we took an application using JDK 6 and upgraded to JDK 8. And then made all these other changes, and we were able to still get things running on a much more updated stack. Now, I'm sure if we'd upgraded to JDK 17 running on WebSphere Liberty, we would have had more issues. But I think the fact that we were able to upgrade so easily is pretty amazing. And it also has a lot to do not only with the Java level, but also has to do with the Jakarta or Java EE level as well, like the JSF backwards compatibility, the Servlet API backwards compatibility. It's pretty amazing stuff. So I think that's a very key thing to consider. So one of the things to remember here, and this is something which I've tried to underscore in this talk, is that the complexity of the project isn't just the code. So it was just upgrading the code to JDK 8 and newer version of Java EE or Jakarta EE. That may not be the most complicated things when it comes to a real legacy project, right? So for us, we had to deal not only with that, but also build CI/CD unexpected integrations, which is actually a big deal. The Okta integration, version control, documentation, etc. So factor all these into your project, and also try and make sure that things that are missing are handled. So again, for us, we tried to make sure that we documented as much as we could, so that the next team that comes along doesn't have to figure out like, basics of how the application works. Same thing with version control, et cetera, and the build process. So at the end of the day, not only did we have all the builds running, using Maven, deploying using Maven, but we had that running in different environments. We also had Jenkins jobs that allowed continuous deployment. Continuous integration, of course, continuous deployment for development mode. And then I'll get to that question in just a second. We also had them do deployment, Jenkins do deployment as well to different environments as well. So we had continuous integration, continuous delivery for development, and then the ability to deploy to different environments through Jenkins. So the question there is one of the best and most useful talks for the whole conference. Awesome, thank you. For detail, tell us more about what your app actually does for context. Okay, so I don't want to get too into the client, but it is an app used for insurance. So it manages stuff related to insurance for end users and also for internal users. That's my vague answer. So thanks for the question. All right, so that's version control, documentation, etc. Okay, and this is another key thing for legacy projects, and it's something that I think we usually learn over time is change as little as possible. Resist the urge to refactor a whole bunch of code because you will undoubtedly break things if you try. This is only safe to do is if you have extensive unit testing, so you can find any regressions right away. And that was not the case for us. We tried to change as little as possible, especially if it had to do with business logic. Anything related to business logic, we did not touch because that business logic had been running for 12 years and it clearly works well enough for the stakeholders involved. QA, again, is very important, very useful. And to me, that was really one of the key things for us making this successful. And of course, you want to make things easier for those who come after you by writing documentation, et cetera, et cetera. So those are, that's the last slide. Yes, it is. Okay, so that's pretty much all I had for you guys today. I'm going to go back to this takeaways graphic here. There we go. And I'll leave it open for any additional questions.
Thank you so much, Kito. I think the only remaining question we have right now is how long did this conversation take? How many people are involved?
Okay, so this organization had a team that wasn't really involved with this project, but this is part of a larger migration project to, like all the other applications we're moving to a cloud, moving to AWS. So our team was just me and Bake, two people. It took, I'd say, the core work only took a couple months, but a lot of it staggered. Some of it's still lingering, so, and a lot of that has to do with availability of all the other dependencies in the project. So core work only 2 or 3 months. The rest of it, is still taking a little bit longer. And neither of us were working full time the entire project on this project. So that's the story.
Thanks. All right. Are there any other questions we haven't answered yet? Now is the time to post them in the chat.
I'm glad my answer helped Brad, so that's good.
Yeah, so like the chat was on fire the whole time. It was awesome to see so many people come together, talking through the different problems and approaches they take to handle these kind of projects.
Yeah, I thought I'd be able to read the chat and keep up with it, but I couldn't. so I'm looking forward to reading it after.
I think we have one person who won the chat who mentioned that they are using Core in their code base. So
okay, so another ancient relic there. Cool. That's when I have not worked with in a while.
So Brad actually has another great question. What was your personal biggest pain point in the whole story?
Personal biggest pain point. I think the biggest thing was figuring out how all the JAX RPC code generation works. I think I might have been better if I had done JAX RPC before. I've worked with SOAP some, and obviously I've been, I was around when the project started, but I wasn't involved in the web services part. I had never done JAX RPC, and it was a total pain to figure out like how they built the thing before, since the code generation was all in the build and wasn't anywhere in the development process. So it took a while to sort of uncover that thing and then get the code generation to be part of the build that a developer could do locally, and that kind of stuff. So I'd say that was it.
Awesome. All right. How can people reach you after the conference?
Best way is on Twitter at Kito99. And also my company is virtua.tech as well. But if you want to just chat, Twitter is the best way.
Sweet. All right. I think we're at the end of the whole thing. No more questions. Oh, actually, there is one more. Can you tell us again why Liberty was not an option?
Yes. Okay. So Liberty wasn't an option because it doesn't support JAX RPC, and we did not have the budget to rewrite all the web services in something more modern. So that was the main reason.
All right. Thanks, Raul, for the question.
Okay.
All right, let's wrap it up here, I would say. Thanks, Kito, so much for being here, giving this talk. I think it resonated very well with people, and it's an important topic. So thank you.
All right. Thank you. Thanks, Benny, for moderating. Thanks, everyone.
All right. Have fun at the conference, everyone.
Yes. You have a couple more sessions.